In this calculator tutorial, I'd like to show you some basic ideas related to the table feature of your graphing calculator. For this example, for this tutorial, I'm going to use the example of y equals 2x squared minus 75x minus 23. And for this quadratic function, otherwise known as a parabola, generally when we graph an equation, we hit the graph key, and we can see the parabola here, at least a tiny little portion of it. Now let's suppose one of my questions was I need to find the x-intercepts for this parabola, and I'm exploring numerically because I have another way to find x-intercepts on my calculator using the zero feature, but that's for a later tutorial. So let's suppose I'm exploring the intercepts numerically. So what I'm going to do is go to my table first. I'm going to, above the graph key in blue is the table. I'm going to do second graph and go to my table. And notice that the table is kind of default set up to start at 0, and the x's increment 1 unit every time. Now what I want to point out to you is above the window key is the table set. I'm going to do second window and go to the table set. And you can see that these two values correspond to what I just mentioned. The table start is 0. And I can see over here in this preview the table starts at 0, and then the delta table is 1. So that's how often it increments my x values. I could do the table start to be 25 if I wanted to, hit enter, and the delta table to be, let's say, 5. Now I can kind of cheat a little because I have this preview window over here. I can see that the table start is now 25 and the x's, the delta table, is 5, so it increments 5 every time. Of course, at home, when you're doing this on your calculator, you would have to hit second graph to go back to the table to see those values take effect. I kind of cheat with the preview window, but at home I wouldn't necessarily have that option. So usually if I'm exploring, what I'm going to want to do is have my delta table be a kind of larger value. A couple things I'll point out to you here is I hit my up arrow. I'm going to notice in my table here or here, this preview window is a little slower. So over here in this big window, notice how the y values are getting larger and larger in a negative direction. And then they start to get smaller and smaller in a more positive direction, I should say. So it looks like the y values are kind of bottoming out around this value. That's one thing that exploring numerically can do for me. I can see some graphical behavior in a table value without actually looking at the graph. So the y values get more negative and they kind of bottom out here, kind of where the vertex might be. So I'm talking about, looks like the graph comes down and then bottoms out and bends back around. And it bottoms out at the vertex, and it looks like that bottoming out is somewhere around x equals 20. But anyway, let's suppose I was finding the x-intercept like I mentioned earlier. Now notice that the y values are negative, 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 and they become positive here. So between 35 and 40, I have a negative y value and a positive y value. Right? And if I look down at this preview here, let's say at x equals 35, my y value is negative, so it's down here somewhere. And at x equals 40, my y value is positive, so it's up here. So to get from a negative y value to a positive y value, I had to cross the x-axis. I had to go through a y value of 0. I would have an x-intercept. So somewhere between 35 and 40, I have an x-intercept. So having a delta table of 5 allowed me to kind of notice that x-intercept in a very broad fashion. Now I could get a little more detailed. What I could do now is go back into my table set. Let me do second window and go back into my table set. And instead of having my delta table be 5, let's go back to a delta table of 1. So when I do second graph now, no, I didn't mean for that to happen. Hang on a second. I wanted to look at x equals 35. Have a delta table of 1. Second graph to go back to my table. Now I'm just looking at a little more kind of zoomed in view, if you will. So now I can see that between 37 and 38, it looks like the x-intercept lies. Again, 37, the y value is negative. 38, the y value is positive. Somewhere between there, we've crossed through the x-axis. So let's get a little more detailed. Let's start our table at 37, and let's do a delta table of, let's say, 0.1. So let's start our table at 37, and let's do a delta table now of 0.1. Now when I go back to second graph at the table, I'm getting a little more detailed view. Now I can see, looks like down here, 37, between 37.8 and 37.9, I hit a y value of 0. Again, 37.8, the y value is negative. 37.9, the y value is positive. Somewhere between there, it has to hit a y value of 0. So I can almost go crazy here and get even more detailed. Let me do table set. I'm going to start the table at 37.8. And now I'm going to do a delta table of 0.01. Let's see if we can get a little more detailed. Second graph to go back to my table. And I can see, look at that. Right between 37.8 and 37.81 lies my x-intercept. I go from a negative y to a positive y. So anyway, the purpose of a table is, if I use a large delta table, I can look at a more, let's say, zoomed out view of the graph. I can see some behaviors of the graph in a little quicker fashion. And if I use a smaller delta table, I can get a little more specific. It's kind of a zoomed in view. One other thing I want to show you about the table, let me go back to the table set menu, is the independent variable. Instead of having it automatically fill the table in for me, I can choose to ask independent values. And look at what this does. If I go back to second graph to the table, instead of the calculator automatically filling that table in for me, now I'm just going to punch a number. And I'm asking for the independent variable x equals 7. When I hit enter, it's going to give me the y value. I'm asking if 2 is the independent variable, hit enter, what's the y value? If negative 3 is the independent variable, I'm asking what's the y value? And what did we do? We said 37.81 and 37.8. Between those two values was my x-intercept. Okay. So, quick summary. In the table set menu, I can start the table at any particular value and increment the x's using the delta table. And if I choose to put the independent variable on auto, it will use those values and automatically fill the table in. Or, under this table set menu, I can change the independent variable to ask by bringing my blinking cursor over to ask and hit enter to darken it. And back in the table, I can ask values and hit enter to give it the particular y values.